This is the first unit of the last chapter for this semester. This chapter deals with conic sections. We're going to deal with three in detail. Conic section, if you remember, is when we take a cone, right, like a dunce's hat, three-dimensional cone. Then if you pass a line or a plane straight through it, take a cross section. This would be a circle. If you come down and you go through it like this, you end up with a parabola. If you go through at an angle, you end up with an ellipse. If you come straight down like this, you end up with what's called a hyperbola. And we're going to deal with all four of these. First one we're going to deal with are parabolas. Okay, let's get some vocabulary down. It's always a good place to start. Here's a parabola. This point right here is called the vertex. This is not anything new. And now there is a point in the middle of this thing, and this will be new. Well, this point, let's go through another one. Right here is the axis of symmetry. And then on this axis of symmetry, we get a point that's called the focus. Now these kind of things, if you look at satellite dishes in cross section, they look like parabolas, and your detector's at the focus because anything coming in is directed at the focus. It will bounce off and it will go straight to the focus. So that's an important little point. Now this distance between the vertex and the focus is P. Okay? And the focus is a point. So we'll have X and Y coordinates. Now there's another point down below us. It's actually a line. So if I go P units in the opposite direction from my vertex, I end up with a line that's called the directrix. And again, if you look at satellite dishes, the directrix is essentially your point of balance of this thing. So if you have a focus here, you have a detector here, this is a point of balance, the intersection between axis symmetry and your directrix. And this is a line. Okay, so that's most of our vocabulary. All right, so if we have, you're used to seeing, well, let's do this. These are the basic formulas for these things. So for parabola with a vertical axis of symmetry, the formula is basically x squared equals 4py. Now this looks a little bit different from what you're used to. The form you're used to seeing is y equals to ax squared. Now if you take a look at this, all we have to rearrange this, all we have to do is divide both sides by 4p. So I have y equals to 1 over 4p x squared, or your a, which is the coefficient you're used to, is going to be 1 over 4p. Okay, you're going to see why this is going to be a little better form for this here in a bit. And p, if you remember, is the distance from your vertex to your focus, or from your focus, from the vertex to the directrix. So that's why we like to have them in this form, if we can. If p is greater than 0, it opens up. P is less than 0, it opens down. Okay. We can also get parabolas with a horizontal axis of symmetry. Okay, and as you'd expect, basically the x and y squared here are reversed. So I'm going to have y squared equals 4px. And again, if p is greater than 0, it opens to the right. If p is less than 0, it opens left. Okay, so with that said, let's go through. I want to introduce another concept. Let's deal with a parabola like this. Here's my vertex. Here's my focus. Now, if we pass a line perpendicular to the line of symmetry through the focus, which would be this line right here. Okay, and we're just going to deal with a line segment where it ends at the parabola. This line right here is called the lattice rectum. And the distance from the axis of symmetry out here is 2p. So the total length of the lattice rectum is 4p. Now if you look at this, and you look at this, and you look at this, then you can see that's a 4p. Now, the length of the lattice rectum, fortunately, has another name. It's called the focal diameter, and it is 4p. So there's your focal diameter. And focal diameter is just the length across your lattice rectum. Focal radius, obviously, is going to be half of that. And by the way, it's the absolute value of 4p. It's just the length. Okay, let's take a look at some examples that are going to look like the homework problems. We're supposed to find the focus, directrix, and focal diameter. Then sketch. Now what you're going to see is I tend to sketch as I go along. So let's take a look at our first example. Y squared equals 4x. And this is what you're given. Alright, so if we come back in, y squared equals 4x. This is going to have a horizontal axis. So it's going to open either left or right. Oh, and by the way, all of these you're going to deal with in this part will have the vertex at the origin. We'll move them around a little later on. For now, we're just going to deal with vertex at the origin. So I know it's going to be horizontal. This is positive. So this thing is going to open to the right. Okay, well, that's good. Now the general form, if you remember, is y squared equals 4px. So 4p is equal to 4. And we solve for p, so p is 1. So to draw your focus, we start at the origin. and I'm going to go 1 unit, and there's my focus. Get the directrix. I started my vertex. I will go 1 unit in this direction. There's my directrix. It will be at x equals -1. And my focus will be at 1, 0. Focal diameter. All right, if you remember from before, the focal diameter is absolute value of 4p. This is 4p. So my focal diameter is going to equal to 4. And that's this distance right here. And you're done. We've got it sketched. We've got the focus. We've got the directrix. And I've got the focal diameter. Probably what you ought to do for me is do focus is at 1, 0. Directrix. It's a line, so you've got to give me the equation. X equals -1. And focal diameter equals 4. So that's that one. Let's take a look at another example. We've got the same instructions. We need to do the same thing. But our equation is going to be y equals 5x squared. All right, well, what we know is that my x squared, my squared term is always by itself. So I'm going to have to rewrite this as x squared equals 1/5 y. I divided by 5. Okay, x squared equals. So if you go back up and take a look at what we did, and x squared equals something, this is going to be vertical. This is positive, so it's going to open up. With the 1/5, this thing is going to be pretty fat. Okay, so we started this. First thing we need to do then is find p. So that's it. So 4p is going to equal to 1/5. We solve for p by dividing by 4. P is 1/20. So my focus, now in this case, I'm going to go up. My focus is going to be right there. So its x-coordinate is 0, and its y-coordinate is 1/20. So it's going to be 0, 1/20. To find my directrix, I go down, -1/20. Since it's horizontal, this is going to be a y equals. So it's going to be y equals -1/20. Focal diameter is really easy. You take the absolute value of this number, so it's going to be 1/5. And we're done. Okay, one more problem. We're going to have a slightly different one. On this one, your instructions are to find the equation with the vertex at the origin. And what you're given on this one is that the focus is at 0, 2. So the first thing I'm going to do is plot this point. X is 0, y is 2. There's my focus. I know it's inside. My vertex is at the origin. So it's going to open up like this. So since that's at 0, 2, my vertex is at 0, 0. The distance from here to here is p. So my P is 2. Okay, this thing opens upward, so I'm dealing with the equation of x squared equals 4py. I plug that in for p, x squared equals 8y. And that is the equation.